In this exercise, we will be using the classic models database, and we'll focus on two kinds of queries, text queries and correlated subqueries. I'm going to do four to five each. Once again, I don't want this video to run very long. The solutions for all of these queries are already posted. You can take a look at. So let's start with the text queries. The text queries, the first two ones, are asking us to find products containing a name, Ford, and also for list products that are ending with ship. Let's start with the first two ones because they're both looking at the same table, which is products. In products, they're probably asking us to look at product name. I'll just type in the text of the queries here, and then we are interested in products, and then we need to look at product name. So I can do product name or bracket product name, same thing, and I'm going to do str here. The first one is asking us to look for products containing Ford, so contains Ford. Now this function is going to give us a true or false, so we will get a mask, and we want to use the mask back again on products to filter the products that contain Ford in the product name, as we can see here. The second one is asking us to do the same, but we need to look for products ending with ship. So I'm going to copy this here. Instead of contain, I want to do ends with ship. We don't have any such product satisfying this criteria. So it could be that the ship has been in the product description. I'm not sure. I'm not very familiar with this data. But anyhow, when we look at product name, there is no product name that is ending with ship on either product description. Okay, so there are none. Let's take a look at the next two questions in the text queries category. Okay, so this one is asking us to report the number of customers in Denmark, Norway, and Sweden, which is in the customers table, and we probably want to look at the country here. Let's copy this question. So we are interested in customers and then country. That's basically the country of our customer. So what we can do, we can construct a mask, and I can construct a mask using the function is in Denmark, Norway, Sweden. That's going to give me a mask, and then I can use the mask again to index my data frame, and I get customers who are in these countries. Where is the country? Okay, Norway, Sweden, and Denmark. There are probably 5 of these. Another way to do it is to take customers here and index it or re-index it using country. If I put country on my index, then instead of masking, I can use indexing again. I can do lock here, and the lock can be also a list of things. That's fancy indexing. So I can do lock and these countries here, and I get basically the same result, those 5 customers, except that country now is on the index rather than being a column. Now the question is asking me specifically about how many customers. So if I want to address this question, instead of listing them, the very last step is to do the length of this data frame. So the answer is 5. Okay, let's take a look at the next question. What are the products with a product code in the range S700 1000 to S700 1499? So this one is asking us to look at the products table, and we want to look at product code. Okay. So this one is interesting. There are 2 ways of doing it. We can either look at product code and match it with a regular expression, or we can look at product code and do a slice on the product code after we make it the index. Let's do both of them. So that's the question here. And we are here looking at products, product code. Okay. So the regular expression way to do it is to basically match it with a regular expression. So we can do str, and then we can do here match. And the regular expression that we want to match is S700. One is the same, and then we need the digits. The first digit should be 0, 1. Well, this is 1. This one is 0, 1, 2, 3, 4. So 0 to 4. The second one can be 0 to 9. And the third one can be 0 to 9. That basically is giving me a big mask here, and I can use my big mask here to index my data frame again, and I get a product which has 700, 1138. The other way to answer this question is to basically set the index to be product code. So I'm going to set index to be product code. Okay, I'm going now to sort the index. This may not be necessary here. I just want to ensure that my index is sorted, because once I do this, I want to slice, and I want a slice from S700 1000 to S700 1499. Obviously, this is string, and this has to be a colon, and this is also a string. And that's basically the same product in this range. There is only one such product. Okay, let's do one more question in the text queries. Which customers have a digit in their name? So that's basically, the customers table. We want to look at customer name. Okay, so let's paste the question here. So customers dot customer name here. That's what we're looking at. And we're interested in customers with a digit. So again, I mean, easily it's a string operation, and we want to use contains here. So we want to have a contain, and I'm going to use a digit. So it's either 0 to 9, one character, or \d for a digit. That basically will give me the mask, and I can use the mask to filter these customers from the data frame. So we have two such customers. What's the name? Okay, toys for grown-ups and gifts for all ages. They happen to have number 4 in between. Again, that can be 0 to 9 or \d for stands for a digit. Now let's go and take a look at some of the correlated subqueries. First question is, who reports to Mary Patterson? And this is a correlated subquery because if you take a look at the employee table, it's kind of has a relationship to itself. Each employee reports to one employee. That's the report to. And obviously then in that case, each employee may be the boss, may have been reported to by other people, by other employees. So that's a one-to-many, it's a recursive one-to-many relationship. Okay, so there are a couple of ways to doing it. One way to do it is just to look up the employee number of Mary Patterson and then look for all employees who have reports to equal to that number. The other way to do it is to join employees with itself and then look for the boss name being Mary Patterson. Okay, so who reports to Mary Patterson? So one way to do it is to look at the employees table here, and I want to extract the number of Mary Patterson. So what I'm going to do here, I'm just going to look for first name equals Mary, and last name is going to be Patterson. Now obviously we can eyeball it, and the number Mary Patterson's number is 1056, but that's not what we want to do, because we want to construct a general solution rather than something that we are doing manually. So, presumably Mary Patterson can be any name, and we need to be able to answer that question. So what I did here, I did one mask, first name is Mary, second mask, last name is Patterson, and adding these two masks is going to give me a big mask, which I can use. I mean, this is a mask, you can see through here. That's the row corresponding to Mary Patterson here. And I can use this big mask here to get the result, the rows that have first name and last name Mary Patterson. Now, obviously, in general, there may be multiple employees with the same name. We don't have it here. We have first name and last name uniquely identify the employee. What I'm interested in is this thing. And this thing is the value corresponding to the first row, first column. So I'm just going to iLock it at 0, 0. That's basically Mary's number. I'm going to call it boss number because conceptually I'm looking up the employee number of the boss. Once I know the employee number of the boss, the next step is to go and look for customers again, sorry, not customers, employees again, and reports to equals to boss number. And that will give me another mask. I can use this other mask to filter the data frame. And this will give me the name of people who reports to employee 1056, who is Mary Patterson in this case. So those are the employees who report to Mary Patterson in the data. So we avoided joining, and that's fine because we only have one. We are being asked to do it for one boss. But what if we're being asked to do it for multiple bosses? In this case, who reports to who in the data? In this case, I want to join employee with itself. So I want to do merge employee, pd.merge employees with employees. And what I want to do, I want left on to be report to, reports to, and right on employee number. So my left data frame is basically the employee, and my right one is the boss. So I can do that, and I will get suffixes here all over the place because those suffixes, there's the same columns. I'm just going to change the suffixes to be something meaningful for me. So I'm going to say suffixes are employee and the boss, because the left one is the employee and the right one is the boss. I'll put an underscore here so I can read it. Okay. So here we go. The last name, so I've got information about the employee here, and I've got information about the boss here. So then the next step is to filter this data frame so that I have last name of the boss and the first name of the boss to be Patterson and Mary specifically. So I'm just going to save this intermediate step here so I don't overcomplicate it, and then I'm going to mask it again. So I'm going to do df dot last name boss is equal to Patterson, and df the first name boss is Mary, and that's my mask here. And then I'm going to mask the data frame again. to get to that result, same people who report to Mary Patterson. All right, let's do one more question in the correlated subqueries. Which payments in any month and year are more than twice the average for that month and year? For example, compare all payments in October 2004 with the average payment for October 2004. Order the results by the date of the payment. So we're looking here at payments here, and we have a field called payment date. And this is asking us to report the payments that are more than twice the average for that month and year. So we want to compare the payment amount to the average payment amount in the same month and year. Okay. Let me copy the question here. Now, to answer this question, starting from the payments table, we first need to calculate the average payment in each month and year, because this information is needed so that we can compare each payment to the corresponding average payment in the same month and year. And if you take a look at the payment date here, we also need to extract the month and year from that payment date. So first step for me is to take a look at payment date. Payment date str, and going from 0 to 7, because I have four characters here for the year, 1 dash, and then 2 characters for the month. That basically will give me the month and year. So the next step is to use this as a group by criteria. So I'm going to do payments group by this thing, and then I want the amount and I want the average, because this is what it's asking me about. That's the average payment amount in each month and year. I have two options here. I can either multiply it by 2 here or just save it as average. I'm going to save it as average here. So let's call this one payment average, and this is the payment average in each month and year. The next step is to basically join this one, join this information back to payment. So what I'm going to do here, I'm going to join payment average to the payment itself. To do this join, I still need this to be a column in my data frame. So actually, I'm going to create a new column. Let's call it payments year month is this thing. Okay, so in my payments data frame, I have this column here, and I'm going to make it an index because I'm going to join it with a series here. So I'm going to set index to be year and month, and then I'm going to join it with this thing, payment average. And I'm going to add a right suffix. This one is complaining about the overlap. So I'm going to put, because this one has an amount, I'm going to put the right suffix, since the right one is the average, to be the average. Okay. So here in each one of these resulting, we have the same rows basically, but we have also the average indicated here. Let's call this one df2. And next, what I'm going to do, I'm going to look for df2.amount greater than twice df2.amount average. That's basically my mask. And then I'm going to mask the data frame again. And that should give me df2, not df. the payments that are twice than the average for the same month and year. Alright, so I'm going to do it in another way. I'm going to avoid joining and I'm going to do it using the group by operation. So first we need this, so I'm just going to paste it here. We need to create the column year month in this data frame. What I'm going to do now, I'm going to group by year and month, and I'm going to take a look at the amount here. Okay, well now rather than doing any aggregation, I'm going to transform each one of these observations in the series amount, and I'm going to transform it to simply true or false. My goal here is to create a mask that only selects these amounts that are larger than twice the average. So my transformation function is basically lambda x. X will be the series of amounts in each one of the year months. X is greater than twice x dot mean. What this gives me a mask which I can use back again to index the data frame. So that's what I get here, and that should be the same results that I'm getting here, although in probably different order. So I can sort, this one is sorted probably by the index here, so I can sort by year months, sort values year month here, and that should give me the same result. Okay, once again, take a look at the POSIS solutions. They include all of the solutions of these questions. As we have seen again and again, there are many ways to get to the same answer, and it has to be conceptually related to what the question is asking for, but there are many ways to perform these operations. And Python and pandas are about giving us options, and options are good, but they require some understanding of them in order for us to make the good choice.